What's up, guys? Welcome back to another AP Calculus video. This is Caleb Chapple, and we're going to be diving into some related rates today. So I'm going to be explaining question 50 from the homework. Let's go ahead and start reading this. It says, a plane flies horizontally at an altitude of 5 kilometers and passes directly over a tracking telescope on the ground. When the angle of elevation is pi over 3, this angle is decreasing at a rate of pi over 6 radians per minute. How fast is the plane traveling at that time? So let's draw a quick picture. So we'll have our tracking telescope on the ground, and the plane flies 5 kilometers over, so 5 kilometers, and it flies past it over a certain distance. We'll call that x. That leaves our plane here. Let's draw a little plane, and that creates a imaginary right triangle. And it also says that it creates an angle of elevation with the ground, which is pi over 3. So we'll draw in pi over 3, which means this angle right here, which we'll call theta, must be equal to pi over 6. All right, so let's figure out what else it includes in the question. So we'll go through and highlight. So it has the altitude of 5 kilometers, which we have in our picture. It has an angle of elevation of pi over 3, which we also have in our picture. And then it also says that the angle is decreasing at a rate of pi over 6 radians per minute. So that means as our angle of elevation decreases, which means it's going that way, our angle theta will be increasing. So our d theta dt, which is derivative of theta with respect to time, will be increasing at that same rate of pi over 6, which makes it positive. So we know d theta dt is pi over 6. And then we know theta is pi over 6 as well. And then we are trying to find how fast the plane is traveling at that time. So that's equal to its speed, or its instantaneous speed, which is also equal to I have the eraser on, dx dt, which is the derivative of x, or the distance with respect to time, which we are trying to figure out. So let's set up a quick equation. So an equation that will get us x. I am going to use tangent because we are given an opposite and adjacent side. So tan theta should be equal to opposite over adjacent, which is x over 5. So let's go ahead and take the derivative of that with respect to time. So d dt of that, and that should be equal to secant, keeps coming to the eraser for some reason. All right, so secant squared theta, which is the derivative of tangent, but since it's with respect to time, we have to use the chain rule on that. So d theta dt, we multiply that. It's equal to dx dt, because we're taking the derivative of x with respect to time, over 5. So since we're trying to find dx dt, we can just multiply by this 5 and get dx dt is equal to 5 secant squared theta times d theta dt, which is also equal to 5 d theta dt over cosine squared theta, because secant squared is also equal to 1 over cosine squared. All right, so we have our derivative. Now we're going to do something that they call plug and chug in Canada. So we'll go ahead and write this over here. Dx over dt is equal to 5 times And we know that d theta dt is equal to pi over 6. So 5 times pi over 6 over cosine, and we know that theta is equal to pi over 6. So cosine pi over 6, and square that. All right, so let's simplify this a bit. Cosine of pi over 6, that is equal to square root of 3 over 2, that's squared. And then you square that, so top times top, bottom times bottom, you get 3 over 4. And then 5 times pi over 6 is also equal to 5 pi over 6. So we get 5 pi over 6 over 3 pi over 4. So since we're dividing two fractions, it's the same as multiplying by the reciprocal. So 5 pi over 6 times 4 over 3, which should equal 20 pi over 18. And that simplifies, let's draw a little arrow down here. It simplifies to 10 pi over 9. So our speed is 10 pi over 9, but we can't forget our units. So we are finding distance divided by time. So our distance unit is kilometers. Is kilometers. And our time unit is minutes. So since it's distance divided by time, it will be kilometers, our distance unit, divided by minutes, our time unit. So the speed of the plane when the angle of elevation is pi over 3 is 10 pi over 9 kilometers per minute. So that's it. That's our answer right there. Solved that equation pretty quickly. Don't forget to like and subscribe. Hopefully you guys found this useful. And as always, if this was helpful to you, I would share that with your friends. And be sure to subscribe to Big Shim. That's B-I-G Shim. And go ahead and like all his videos. He posts some amazing content, guys. And I'll give you a friendly reminder to enroll with dual enrollment at TW, because you can't forget to do that. That might ruin your math career if you forget to do that. And I'll leave you guys with a quote from Mr. Noel. You need to try the Baja mac and cheese.